My name is Mahadeva K.R. I studying in SVC College of Engineering in Bangalore. My section is Astroset. My subject is DSDB. My explain about topic is design of 4-bit asynchronous counter. 4-bit asynchronous counter. Design dive into the world of asynchronous counter, exploring the design, implementation, and application. This presentation will cover the fundamental asynchronous counter, a step-by-step design of a 4-bit asynchronous counter, and the advantage and disadvantage of this type of counter. Introduction to asynchronous counter fundamentals. Asynchronous counter use flip-flop that are not clocked simulation. The clock signal is passed from the one flip-flop to the next, creating ripple effect. To this means that the output one flip-flop acts as the clock input for the next. Ripple effect. Asynchronous counter are known for their ripple effect, where these changes on flip-flop trigger a chain reaction in subsequent flip-flop. The propaganda delay associated with each flip-flop adds up, causing in the overall counting process. Fundamental as asynchronous counter we have a flip-flop. The core of an asynchronous counter is a series of flip-flop, typically types flip-flop, where the output of each flip-flop triggers the clock input of the next clock signal. The clock signal is applied only to the first flip-flop. Subsequent flip-flop are clocked by the output of the previous flip-flop. Counting sequence. The counter's output changes as the clock signal triggers the flip-flop, creating specific counting sequential, usually binary. Propaganda delay. The delay clock signal the output of each program delay. The counters of output clock signal trigger flip-flop, creating sequential using binary. Two. Design for of a 4-bit asynchronous counter. Flip-flop configuration. If a bit asynchronous counter requires 4D type flip-flop connected as cascade configuration. Clock input. The clock input is applied to the first flip-flop, and the output of each flip-flop serves as the clock input for the next output. The output of the four flip-flop represented the binary count value ranging from the 0000 to 1111. Counting sequence. The counter will be flow specific counting range from flip-flop 1111 and then reset back 0000. Implementation using D flip-flop. D flip-flop are widely used in asynchronous counter because their output follows the input signal on the rising or falling edge of the clock signal. Input and output. The D-type flip-flop as a data input. D and output the value, and on D input transfer to the Q output on the clock active edge. Cascading flip-flop. The output of an flip-flop acts as the clock input for the next flip-flop in the cascade, creating a chain reaction for counting. Timing consideration and propagation delay. The propagation delay of each flip-flop is the time it takes for the output to change after the clock signal triggers. The cumulative program propagation delay of flip-flop in the cascade determined counting time and can affect the accuracy of the code. The program propagation delay introduces an counting process. The overall counting time and can specifically when the output frequency is programmation delay is high. Advantage of asynchronous counter. Simple design. Asynchronous counter are simple to design and implementing, requiring fewer components than synchronous counter. Cost effective. Their simplicity makes them cost effective compared to synchronous counter which require more complex logic. Asynchronous counter offer flexible in terms of specifically makes them cost effective compared to counting sequential but adjusting flip-flop connecting. Disadvantage of asynchronous counter. Propagation delay. The main disadvantage of asynchronous counter is propagation delay associated with each flip-flop. Counting accuracy. The cumulative propagation delay can lead to inaccurate counting, specifically at high clock frequencies. Application of asynchronous counter. Digital clocks. Asynchronous counter are used in digital clocks to keep track of time, disabling seconds, minutes, and hour. Traffic lights. They are essential in traffic light controllers to manage the sequence of traffic lights, ensuring safe transition. Digital display. Asynchronous counter find application in digital display in electronics, ensuring safe transition and devices and TVs. Then finally, they finally end up PDF in end of topic in conclusion and key takeaways. The asynchronous counter while simply and cost effective and have limitation due to programmation delay, understanding their characteristics, advantages and disadvantages is crucial for choosing the right counter of your application. The ability adapt and modify a synchronous counter makes them various selection application from clocks. Thank you.